Hi guys, I'm Robert.
And I'm Travis.
Today in our endothermic reaction, we'll be using the materials water, a 250 milliliter beaker, a plate of wood, a stirring rod, a thermometer, and we'll just be discarding our waste into the waste bin.
And our chemicals that we're going to be utilizing are 16 grams of barium hydroxide and around 8 grams of ammonium thiocyanate.
We will begin our experiment by placing water onto the wooden block. We will then place the 250 milliliter beaker on the wooden block. Ensuring that this is in place, we will then place 16 grams of barium hydroxide inside of the container.
Immediately following that, we will then add the 8 grams of ammonium thiocyanate into the beaker. And after that's added, we will stir the chemicals with a stirring rod. And as they're mixing together, whether you may or may not be able to see, the chemicals look like they're almost melting into like a slushy type of substance. This is essentially the endothermic reaction taking place, where heat is being absorbed by the solid substance from the warmer water underneath the beaker, which should essentially bring the mixture to a below freezing temperature, which we will now observe with the thermometer. And as you can see, the temperature is dropping rapidly towards 0 degrees, which is the freezing temperature in Celsius.
As a result of our endothermic reaction, the beaker is then going to freeze to the plate of wood.
Ooh. They're supposed to freeze. We'll get back to that. We'll check on that in about a minute or so.
According to PubChem, GHS classification of barium hydroxide is classified as very dangerous. It can be harmful to the eyes and to the skin because it is corrosive. It can also be dangerous if it is swallowed or inhaled. This is why we be utilizing a fume hood.
Also, according to PubChem, the GHS classification of ammonium thiocyanate isn't as dangerous as the barium hydroxide, but it does want to remind its users that if it comes in contact with the skin or if it is inhaled or swallowed, that it can be very harmful. So that's why we'll be utilizing the gloves, the apron, and the goggles just to avoid all that. Also, it is very harmful to marine life. It can cause long-lasting damages. So we will be disposing of the chemicals inside the proper waste container.
According to online labs, the reaction undergoes an endothermic reaction, taking the heat from its environment.
So like Rob said, that's essentially what an endothermic reaction is, when chemicals absorb heat from the surrounding environment, which will essentially cause a decrease in temperature, positive heat flow into the reaction, and an increase in enthalpy, which is change of heat within the reaction.
One real-world application of an endothermic reaction is the refrigerating process. Within the refrigerating process, there is a liquid called refrigerant. This refrigerant it evaporates at a low temperature, causing the contents inside of the refrigerator to maintain their coolness. So this part right here is called the compressor. The refrigerant gas is compressed by the compressor right here, and then it heats up because it is then pressurized by the coils, and it goes into the coils, and these coils dissipate the heat, and then it turns it into a liquid. And as it is turned to a liquid, it goes into the expansion valve, which is C. This expansion valve can be thought of as a small hole. So the pressure on this side is high, but the pressure on this side is low due to the compressor sucking the gas from the inside of the refrigerator. After the liquid refrigerant goes through the expansion valve, It is then boiled and vaporized, and the energy from the vaporization is used inside of the refrigerator to maintain its coolness.
So another real-world application, according to the University of Illinois Chemistry Department, is just ice melting. So let's say you have a warm drink, or whether it's me just setting ice onto here. With the ice melting, it's essentially absorbing the heat from either the warm drink or the surrounding environment that is cooling it down, causing the endothermic reaction. So let's say it's a really hot summer day, you're dying of thirst, there's nothing in the fridge, and your mom left the lemonade out to get warm essentially because she forgot to put it in the fridge after she went grocery shopping. So you pour yourself a glass of lemonade and you put ice into it. That ice, when you put it into the glass, is going to cause the endothermic reaction. Heat is going to be absorbed from the warm lemonade to the ice, which is the positive heat flow into the reaction, and a change in enthalpy is going to increase as the temperature decreases within the lemonade. So let's check on the beaker now. Oh, yep, see, there's the results we were looking for. And so that is our demo experiment. I'm Travis.
And I'm Robert.
And thanks
Thank
for watching,
you.
guys.